Reverse Engineering Product Redesign presentation by Sophia Rodriguez. Design Challenge. Students working for a flashlight company will redesign our competitor's flashlight product in order to consequently benefit the company and overcome and surpass our competitors. New design specification. This is our new design specification table. The following data was obtained from the 5 tests we conducted: the brightness, portability, quiet operation, crank, and durability test. These tests allow my team members and I to gather enough information to create our specification for the new design product. After taking my other team members and the customer needs into consideration, we finalized the new design to have an average of 2,000 lux, the mass to be 100 grams, the produced sound from the crank to be less than 10 decibels, for the force needed to push the crank to be at less than 10 newtons, and lastly, for the durability of the flashlight to be at a high standard, where the flashlight is intact and not broken after being dropped from a measurement of 100 centimeters in the air. Predictive/imaginative view. This imaginative sketch was created before my team members and I knew what was in the interior of the crank flashlight. That being said, when creating the sketch, I believe there were various mechanics that were used to generate the light inside of the flashlight. I imagined that when the crank was pushed down, it causes the gears to move against one another in order to generate energy. This energy is then connected through the light sources and is converted into light energy to produce the light inside of the flashlight. That being said, once the light sources lose energy, the user can push the crank continuously to maintain the amount of energy that converts into the power source. Exploded view. From our set of tests, we included a drop test, which tested the durability of the flashlight, consequently leading our flashlight to break into multiple pieces. This allowed us to create an exploded view of the disassembled flashlight where we laid out different parts that were built together. That being said, after taking a look at the exploded view of the flashlight, my peers and I saw that there were, in fact, various gears that were compatible with one another and were activated by pushing the crank in order to move with each other and generate the light coming out of the flashlight. However, in our imaginative sketch, I did not include any of the small and key features that are incorporated into the flashlight in order for the product to functionally work. Our imaginative sketch was an example of a more simplified version of the actual design of the flashlight, but it was a good starting point to understand the dynamics of the flashlight itself. This allowed my team and I to understand what parts needed to be included in our new flashlight and how mechanical energy is generated from the compatible gears that create energy that is then sent to the wires connected to the light bulbs in order to produce the light. This allowed my team and I to include a solar panel and multiple batteries to create more energy that will then be supplied into the light bulbs in order to, 1, create a brighter light, and 2, have 2 sources of energy, which consequently allows the light to last for a longer period of time. Design process. Firstly, my team and I jotted down different ideas and priorities we would like to incorporate into our final design. This included topics such as different power sources, aesthetics, durability, and more. Having said that, we compiled all of these ran out ideas onto our post-it notes and grouped them into different categories to see which had the most ideas written down for. Subsequently, leading our group to focus on the most desired elements in our design, those being ideas such as durability, efficiency, and light source. This allowed my team and I to gather all the information needed to create our final redesign. After creating 3 designs in our C-sketch, my team and I decided to pick the first idea, which was to incorporate solar-powered energy into our flashlight. That being said, we chose this because we decided to focus on our customers' needs of efficiency. And the solar panels allow my team and I to design a flashlight that best supported the need of efficiency, as it allows the customers to maintain energy without having to charge the flashlight or change its batteries. Therefore, we did not choose idea 2 because we did not want our customer to have to change the flashlight batteries or have to crank energy into the flashlight. Also, we decided not to continue on with the third idea because the colored lenses would be too complicated to embed into our design and isn't our main priority/concern for our customers. This is why we chose to go with the first idea, which are the solar-powered flashlights. Technical drawings. Our final redesign was fundamentally built off of many designs combined into one another. First of all, my peers and I, final design consists of two sources of energy, those being the embedded solar panels and the rechargeable batteries inside of the flashlight. Having said that, the solar panels would be used to transport electrons from the sunlight it collects all the way to the inverter, which creates the energy needed for the flashlight to illuminate light. Therefore, the energy obtained from the solar panels make their way to the LED bulb wire and through the jumper cable, which can then be transferred to the rechargeable batteries. This allows electricity to be formed inside the flashlight, which travels to the wires and connect to the LED light bulbs. These LED light bulbs accept the energy coming from the wires in order to generate heat and electricity to produce the light coming out of the flashlight. This ensures the maximum amount of energy the flashlight can obtain among intervals to allow the flashlight to last for long periods of time. Moreover, my team and I went to every situation our customer might be in into consideration in order to make the best possible redesign that will fulfill the needs of our customers. That being said, my team and I wanted to guarantee that the customer would be able to access the flashlight in situations where their surroundings are not visible and are surrounded by complete darkness. To do this, we embedded a glow-in-the-dark power button that is surrounded by texturized circles so that a customer can automatically have a clear visual and have a sense of the power button in order to activate the flashlight. Additionally, my team and I included a glow-in-the-dark O-ring to allow the customers to access the flashlight quickly, as it is clearly visible in the dark. Moreover, the flashlight included a polymer grip around the base of the model and an adjustable strap, which allows the user to maintain a comfortable position and grip on the flashlight in order to use it without any struggle or pain. This also enables the customer to comfortably hold the flashlight either by the polymer grip or by the strap for easy usage and portability. Last but not least, the exterior of our flashlight is built off of metal to acknowledge the customer's request for high durability and a flashlight that could withstand drops from different angles without breaking. Concept selection was different for the flashlight compared to the camera because with the camera we were restrained to a very particular amount of materials that we could be used, which are in the directions that we followed to build the camera. While the concept selection for the flashlight allowed my team and I to use full creative range, as we could use any material we believe would be necessary to operate the flashlight. This allowed us to create completely different designs in our sketches because we were given a great range of customer needs to focus on, while the camera subjected us to answering those with limited hand dexterity. Last but not least, this is our final redesign of our flashlight. Our flashlight design has shown numerous reasons as to why customers should be attracted to our product rather than the designs of our competition. First, the flashlight has restorative energy from the solar panels, which then travels to the batteries, then consequently gets converted into electricity to produce light. This allows our customers who are seeking a flashlight that can last long periods of time without having to charge it. It allows our customers who are always on the go, outdoors, and just need a reliable flashlight to be able to depend on this flashlight that can use natural resources such as sunlight to produce energy to function. 2. The flashlight has a glow-in-the-dark ring inside of the bezel, as well as a power button that is surrounded by texturized circles, which allows the customers to find the flashlight in the dark when their surroundings aren't visible anymore. It prevents the struggle customers may face when in the dark and allows them to find the light quickly. 3. Our flashlight is durable, has comfortable grips, has a strap, and is big enough for all ages to hold it properly. This shows that our flashlight is comfortable and is available for all usage of all ages, demonstrating that our flashlight is not limited to a certain group, unlike our competitors. These reasons demonstrate the uniqueness behind our flashlight design and why customers will be more attracted to our product rather than our competitors' designs. Thank you so much.